Good morning, everyone. In the previous class, we have learned about the definition for curves. What is a curve? What are different types of curves? What are the elements of simple circular curve? We have learned about the relationship between radius of curve and degree of curve. Along with that, we have learned the methods to setting out the curve in field by chain and tape as well as by uh, angular methods. So we have learned all these things. With this background, we can start some numericals. In this class, I want to cover uh, different varieties of problems related to curve setting. So we will learn every method of curve setting in this class. So let us start the class. Here we have a problem. Two tangents intersect at a chain of 1250 meters. The angle of intersection is 150 degrees, and he is asking to calculate the data necessary for setting out a curve of radius 250 meter by diffraction angle method. He has given peg interval as 20 meters, and now we have to prepare a setting out table. Before solving this problem, we need to solve some basic problems which gives us better understanding in solving this type of problems. So we will go to the basic level problems. So we'll start from there so that it will be easier for us for this type of problems. Let us solve this problem. Determine the offsets to be set out at half chain interval along the tangents to locate 16 chain curve. The length of each chain being 20 meter by radial offsets and perpendicular offsets. So here we have to construct a simple circular curve using radial offsets and perpendicular offsets. It has given some information. Each chain is 20 meter long. So here we have to set an offset at an interval of half chain, means at every 10 meter interval we have to set an offset along the tangent to locate 16 chain curve. So let us solve this problem. We have already derived the formula for offsets in radial offsets method. So this is nothing but radial offsets drawn to the tangent. We have the formula for radial offset. Ox is equal to under root r square plus x square minus r, where r is the radius of the curve and x is the distance from the starting point of commencement of the curve. It depends on given peg interval. He has given peg interval as 0.5 chain, nothing but a 10 meter distance. So we'll take 0.5 meter, 1 meter, 1.5 chains, 1 chain, 1.5 chain, 2 chain, etc. So for given x value, we have to calculate ordinates, different radial offsets. Here r is 16 chains. The radius of the curve is given as 16 chains. Means 16 into 20 meters, 320 meters. Here we no need to convert the values into meters. We can directly calculate in terms of chains. Then we can convert into meters. So let us substitute r value. R square means 16 into 16. X value is x square. X square means 0.5 into 0.5. Here r value is 16. So 16 into 16 will get 256. This is 0.5 into 0.5 minus 16. We will get 0.0078 chains. Each chain length is 20 meters. If we multiply, we will get 0.16 meters. Therefore, the offset at a distance of 0.5 chains means half chain is 0.16 meter. This is the radial offset at a distance of 0.5 meter. Similarly, at 1 meter, if we substitute, we will get 0.62 meter. In the same formula, we have to substitute, but here x value is changing. Here it is not 0.5, as the chain is 1 meter, 1 complete chain. We have to substitute 1 here. 1 square means 1. So we will get 0.62 meters. In the same manner, we have to substitute for different chain lengths. So we have substituted for 0.5 chains, 1 chain, 1.5 chains, 2 chains, 2.5 chains, etc. So these are the offsets. These are nothing but radial offsets. Using these radial offsets, we have to construct a simple circular curve. Let us see how we have constructed. So this is nothing but our tangent. From tangent, he has drawn radial offsets. He has drawn radial offsets. So based on the calculated radial offset values, we have to draw a perpendicular, a radial line at different distances, and joining these points we will get a simple circular curve. In this way we will solve radial offsets method problem. Now let us see how we will solve perpendicular offsets from tangent. For this also we have derived formula for offset. Here offset is nothing but r minus under root r square minus x square, where r is the radius of the curve, x is the distance from tangent, where we want to calculate the offset. So this is nothing but distance from the commencement point, where we want to calculate the offset distance. For different chain lengths, we have to calculate offset values. So the x value is changing here. So for half chain, offset value will be 0.116. For one chain, it is 0.62. For 1.5 chains, it is 1.41 meters, and so on. Here the x value is changing. We have to change x value for a given x value. The y value will be changing. After calculating all the offsets, these offsets are drawn to get the simple circular curve. So these offsets should be perpendicular offsets. These are not radial offsets. These are perpendicular offsets like this. So we have to draw perpendicular offsets from the tangent. After joining all the perpendicular offsets, if we draw a simple curve, we'll get a simple circular curve. Here OX is the offset distance, X is distance on the tangent at which we are going to calculate offset. For different X values, we will have different ordinates. All these ordinates are joined to get simple circular curve. So this is how we will solve for tangents from a radial offset and perpendicular offsets, ordinates from tangents. We will go to the another problem. Two tangents intersect at a channel of 59 plus 60. Some of the people may get doubt what is a 59 plus 60. Here 59 means 59 complete chains. 60 means 60 links. So we have to convert the total value into meters. Then this means 59 chains and 60 links. Each chain length is 20 meters. Each link is 20 centimeter. So by that we can convert the uh, Chinese of intersection point. The deflection angle being 50 degree 30 minutes. Calculate all necessary data for setting out simple circular curve of 15 chains radius to connect two tangents if it is intended to set out curve by offsets from chords. Take a peg interval of 100 links. 100 links means 20 meters. Length of chain being equal to 20 meter. Here he is asking to construct a simple circular curve using offsets from chords produced method. He has given a Chinese of intersection point as 59 plus 60. It means 59 chains and 60 links. The deflection angle is 50 degree 30 minutes and the radius of the curve is 15 chains, which means 15 into 20 meters. It is 300 meters. Peg interval is given as 100 links, which means 20 meters. Length of the chain is 20 meters. So depending on the given data, we have to set the simple circular curve by method of chords, offsets from chords produced. First of all, we have to calculate the tangent length. I uh, uh, initially discussed that we need to remember all the formulas for 5 elements of simple circular curve. So here we will use those some of the elements. Here first one is tangent length. You know the formula for tangent length is r tan delta by 2. R value is 15 chains. So if you substitute here 15 into tan delta by 2. The deflection angle is given as 50 degree 30 minutes. So half of the angle will be equal to 25 degree 15 minutes. If you multiply this, we will get 7.074 chains, which means 141.48 meters because each chain length is 20 meter. Then length of the curve is given as pi r into delta by 180 degrees. We have already derived the formula for length of the curve in the recent class. So if you substitute r value and delta value here, we will get length of the curve also. So which is 264.42 meters. Chinese of point of intersection is given as 59 plus 60 links. So 59 means 59 chains, 59 into 20 plus 60 links. 60 links means 60 into 20 centimeter. So we will get 1192 meters. So Chinese of starting point of the curve is Chinese of intersection point minus tangent length, because the Chinese of intersection point, if you subtract the tangent length from the Chinese of intersection point, we will get the Chinese of point of commencement, which is nothing but starting point of the curve. So that is 1050.52 meters. Now, if we want to calculate Chinese of point of tangency, then we have to add the length of the curve to the point of commencement. So we have already calculated point of commencement. Here we have to add length of the curve. So for getting point of tangency, we have to add a Chinese of starting point of the curve to the length of the curve. Point of tangency is starting point Chinese is 1050.52 plus 264.42 meters. So we will get 1314.94 meters. So length of first subchord is nothing but 1060 meters minus 1050.52. So here we are taking the first subchord as from the starting point of the curve. So let us take next rounded figure to 10060. Now we will get first subchord as 9.48 meters. Remaining all subchords will be equal to 20 meter length. So last subchord will be 1314.94 minus 1300. Here we'll get 14.94 meters. So like this, we have to divide the entire curve into number of parts. The first and last parts having different values, and all the remaining points will be having same value, which is nothing but peg interval, which is equal to 20 meters. So here we have divided into 12 parts, 12 equal parts of 20 meter length and 9.4 meter and 12.49 meters. Therefore, total number of cards is 14 because equal cards are for first and last cards. If we add, we will get 14 cards. Length of final offset, we have the formula as C1 C square by 2R. So C square means first offsets 9.48 whole square by 2 into 300. We will get 0.15 meters. The length of second offset O2 is equal to C2 into C1 plus C2 divided by 2R. If you substitute the values of C1, C2 and R, by substituting C1, C2 values in the equation, we will get length of second offsets. So O3, O4 until O12 are same because the C1, C2, C2, C3, C4 values are same. Similarly, we have to calculate the last offset. It is nothing but C by 2R into Cn plus Cn minus 1. We will get 0.87. So this is how we will calculate different offsets in cards produced method. First, we have to divide the curve into different parts, different equal parts, and then we will round it off the first offset and we will adjust the last offset. By that, we will count the number of cards. Then we will calculate the different offset lengths. By calculating offset length, we can set the curve in the field. We have another problem. Two tangents intersect at a channel of 101 plus 60. It means I have already explained in a recent problem. 101 means 101 chains. 60 indicates 60 links. So each link is 20 centimeter. So 60 into 20 centimeter will get 12 meters. Therefore, 101 chains means 101 into 20 meter chain plus 12 meter. This is the Chinese of intersection point. The chain used in 20 meter with 100 links. So here he has used the chain of 100 links with 20 meter length. Calculate the necessary data for setting out curve of 250 meter radius to connect two tangents. The deflection angle is 46 degree 30 minutes. Take the peg interval as 100 links. Use the method of offsets from cards produced. This is also the similar problem to the previous one. So first we have to calculate the tangent length. Tangent length, the formula for tangent length is arctan delta by 2. We know the R value, which is already given in the problem. Delta is also given in the problem. This is 46 degree 30 minutes. If you substitute these values, we'll get tangent length as 107.41 meters. Length of the curve is pi r delta by 180 degrees. So R value is given, delta is also given. If you substitute these values, we will get length of the curve. Chinese of point of intersection is 101 plus 60 links. 101 means 101 chains. Each chain length is 20 meter. If you multiply with 20, we'll get number of meters of channels. And we have 60 links. Each link is 20 centimeter. It means 0.2 meters. So this is 101 into 20 plus 60 into 0.2. We'll get 2032 meters. Chinese of T1. T1 is point of commencement. If you want to calculate Chinese of T1, we have to subtract the total Chinese of point of intersection from the tangent length. So we have calculated the point of intersection Chinese as 2032 meters. We know the tangent length is 107.41 meters. So Chinese of T1 is 2032 minus 107.41 meters, which is equal to 1924.59 meters. Chinese of T2 is nothing but Chinese of T1 plus length of the curve. So length of the curve is already calculated. If you substitute these values, you will get Chinese of T2 as well. So Chinese of T2 is 2127.3 meters. After calculating Chineses and curve length, now we have to divide the curve into sub parts. Change of each peg will be at 20 meter interval. So length of first upcut is 1940. Let us round off the first part to 1940. So we will get 15.41 meters. Length of last subcut will be 106 plus 36.9 minus 106. This is 7.38 meters. So number of full cards will be we'll have 9 full cards. From this, the first subcard plus last subcard, and we have 9 normal cards. The total number of cards are 11. So length of first offset, we know the formula. It is c square by 2r. First subcard length is 2.41 meters and r value is 250. If you substitute these values, we will get O1 value, which is 0.47 meters. And then we have O2. O2 is equal to C2 into C2 plus C1 by 2R. C2, C1 are 2020. So we substitute these values to get O2 value. Similarly, O3, O4 until O10 are same because these are all having same subcards lengths, which is equal to 20 meters. So last length of offset is something different. So we have to substitute the values to get last length of offset. It is 0.41 meters. In this way, we will calculate different offsets from cards produced. So now we will learn how to set out a curve by one theodolite method. Using one theodolite method, this is called setting out curve by angular method. Till now we have discussed setting out curve by chain and tape. This method will be in setting out curve by one theodolite method comes under angular method of curve setting. Here AB and BC are two tangents intersecting at point B. T1, T2 is the long chord. This is long chord. We will learn how we are going to set the simple circular curve using one theodolite method. This is the procedure for which the curve is constructed using one theodolite method. First, we have to calculate the tangent length and curve length. The tangent points T1 and T2 are fixed. Length of the curve is pi r, phi by 180 degrees. R value means the radius of the curve. Phi is the deflection angle. Tangent length is r tan phi by 2. So these things first we have to calculate, and then ascertain the length of initial and final subcards and number of full cards. Calculate the deflection angle for the cones. Verify the deflection angle delta is equal to 1718.9 by R into L. Arithmetic check: if you apply, the sum of all the deflection angles must be equal to 5 by 2. Now, after calculating all the values, that means delta 1, delta 2, up to delta n, all the deflection angles, we have to prepare a table and then set up the theodolite over T1. T1 means point of commencement, and level it. Vernier A is set to 0 degrees of main scale. Keeping the upper clamp in fixed position, the lower clamp is released. Bisect the ranging rod at intersection point P perfectly with the help of lower tangent screw. For minor adjustments, we will use a lower tangent screw. Then we have to tighten the lower clamp before taking the reading. So I repeat again: set up the theodolite at T1. T1 means point of commencement, and level it. Then vernier A is set to 0 degrees of main scale. Keeping the upper clamp in fixed position, the lower clamp is released. Bisect the ranging rod at the intersection point P perfectly with the help of lower tangent screw, which is also called slow motion screw. Then tighten the lower clamp. Now release the upper clamp. Set the first deflection angle delta 1 on vernier A. Direct the telescope along T1E. Hold the zero end of the tape at T1 and measure the length of initial subcord T1 P1 such that the ranging rod at P1 is also bisect the telescope. Lower the telescope to mark P1 on the curve perfectly. Mark P1 by a nail or a arrow which is supplied at the time of a survey. Set the next deflection angle delta 2 on vernier A. Now mark P2 such that P1, P2 is equal to length of full chord. First we have to take rounded off value for the first subchord. Then we will take full chords until the last chord. P2 is the next point on the curve. Continue this process until deflection angles are set out and mark all the points on the curve. The last point should be coinciding with T2. T2 is the last point of the curve. Then calculate the amount of error in last point does not coincide if last point does not coincide with T2. In some cases, due to least count of the instrument, the last point may not coincide. Then in such cases, we have to calculate the total error. If the error is small, we have to distribute the error along all the subchords with respect to their length value. If the error is large, that means we have to repeat the procedure. If it is small, we can distribute the error. If it is large, then we have to repeat the entire procedure again. So this is how we'll construct simple circular curve using one theodolite method. In this method, the observations are we have to measure all the deflection angles initially. Then we have to start from T1 and keep on setting deflection angles from T1. And we will be moving from T1 to T2 until the last point is reached. In this process, we will get different points on which we can construct the simple circular curve. Now we have another method called two theodolite method of curve setting. This is generally employed in railway curve setting as it gives correct location of points. No chain or tape are required for fixing the points on the curve. Mostly suitable when the ground surface is not favorable for chaining and the chain is not used if the ground surface is undulated, in such cases we would use this two-theodolite method for curve setting. So the procedure is as follows. We have to calculate all necessary data, and then we have to prepare a setting out table by which we will set out the simple circular curve. After preparing the setting out table, we will learn how to prepare setting out table in the coming classes. For now, we have to prepare the setting out table, then mark the tangent point T1 and T2 on the ground. Then center the theodolite over T2 and level it. So first we have to put a theodolite over T2 and we have to level it. Set vernier A to 0 degrees and tighten the upper clamp. Release the lower clamp and turn the telescope to bisect the ranging rod at T1 perfectly. So the instrument is centered over point T2 and another instrument is centered at point T1. So we have two theodolites from which we are constructing simple circular curve. Now take off the ranging rod at T1, set up the center, set up and center another theodolite over T1 and level it. Now we understand that there are two theodolites used in this method. One is at T1 and another is at T2. Set vernier A to 0 degrees and tight the upper clamp so that angle will not be changed. It remains 0 degrees. Release the lower clamp and bisect the ranging rod at B. The lower clamp is now fixed. Release the upper clamps of both the theodolites. The first deflection angle 1 is set out on vernier A of both the theodolites. The point P1 is located such that lines of such line of sight of both instruments intersect at P1. At deflection angle delta 1, if you put two theodolites, we have two lines. These two lines will be intersecting at a point called P1. So this P1 lies on the curve. Then set the next deflection angle delta 2 on a vernier A on both the instrument, which means we have to add delta 2 to delta 1. So this is nothing but a cumulative value. P2 is located as the point of intersection of lines of sight on both the instruments. So P2 is the next point on the curve. This process continues until all deflection angles are marked. The total deflection angle delta is set out in both the instruments. The line of sight of theodolite T1 should bisect T2 and the line T2 should bisect point B because we have set a complete deflection angle. So this is how we will construct. The line of sight of theodolite at T1 should bisect T2 and that of theodolite T2 should bisect B. This is how we will construct a simple circular curve in two theodolite method. So let us solve some of the problems regarding deflection angle method. Two tangents intersect at a channel of 1250 meters. The angle of intersection is 150 degrees. Calculate all necessary data for setting out a curve of radius 250 meter by deflection angle method. The peg intervals may be taken as 20 meter. Prepare setting out table when the least count of the vernier is 20 seconds. First of all, we have to calculate the changes of first point and changes of last point of the curve. For that, we have to calculate tangent length, curve length, changes of first point, etc. So the given information is radius of the curve is 250 meters. He has not given that deflection angle directly, he has given intersection angle. So we have to measure deflection angle, which is nothing but 180 minus intersection angle. So 30 degrees is the deflection angle. Change of intersection point is given as 1250 meters. Peg interval is 20 meters. Least count of the vernier is 20 seconds. So we know the formula for tangent length, which is r tan 5 by 2. So r value is 250, phi value is 30. So we will get 67 meters. We know the formula for curve length, which is pi by 180 into r5. So r value is 250. If we substitute these values, we will get curve length. Change of first starting point of the curve is change of intersection point minus tangent length. So we will get 1183 meters. Change of second point means the last point in the curve, T2, which is equal to starting point change plus we have to add curve length to this to get change of last point. So we will get 1313.89 meters. Now we have to divide number of subcards. Let us round off the figure to 1190 so that we will have the first subcard as 7 meters. Length of final subcard is 13.89 is the last point. 13.89 is the change of last point. So we will have 3.89 meters as the last card length. In between, we will be having number of full cards of 20 meter length, which equal to 6 full cards. Chinese covered is up to 1310. So deflection angle for the initial subcard is, we have the formula for delta 1, which is 18.9 by r into initial subcard, which is 7 meters. If we substitute, we will get 0 degree, 48 minutes and 8 seconds. Similarly, we have to calculate the deflection angles for full cards, which is equal to 2 degrees, 17 minutes, 31 seconds. This is same for all the full cards. Deflection angle for final subcard is delta n is equal to 18.9 divided by r into last subcard length, which is 3.89 meters. So we will get 0 degree, 26 minutes, 45 seconds. Here we will be having a arithmetical check. If we add all the deflection angles, it should be equal to half of the these deflection angles by Rankine's method. We will add all the values. We will get 50 degrees. So approximately 15 degrees, which is therefore the check is correct. Then we have to prepare a setting out table. It will be like this. It indicates different points on the curve. Chinese means this is Chinese of T1, Chinese of P1, etc. Path length means the distance between two Chineses or 2 points on the curve is nothing but card length. Here we will be having 7 meter distance. After that, all the cards will be having 20 meter distance, and the last card is 3.89 meters. Deflection angle for the card is, we have already measured the different deflection angles. This is 0 degree, 48 minutes, 8 seconds. And for all full cards, we will be having same value. And for the last card, the value is different. This is total deflection angle or cumulative deflection angle. We have to add the first value to the second value and write it here. Then we have to add these two values, write it here. Similarly, we have to calculate all the cumulative angles. These angles we cannot directly set in theodolite. Therefore, we have to adjust the values based on least count of the instrument. So least count here is 20 seconds. We cannot, this is 8 seconds, means we cannot take it as 20 seconds. This is nearer to 0 seconds. Therefore, we can write it as 0 degree, 48 minutes, 0 seconds. Here, if we observe, we will have 39 seconds, which is nearer to 40 seconds. So we can take it as 40 seconds. Here also, it is 10 seconds, which is nearer to 0. Sometimes it can be taken as 20 seconds. Sometimes it can be taken as 0 seconds. For 41 seconds, we can directly say rounded off value as 40 seconds in the instrument. For 12 seconds, we have to take 0 seconds. For 43 seconds, we have to take 40 seconds. For 14 seconds, we have to take 20 seconds, like that. So this is 15 degrees. So T1 is nothing but starting point of the curve, and T2 is nothing but last point of the curve. Based on this, we have to set the simple circular curve using single theodolite method or two theodolite method. We have explained these two methods also. By having all these values, we can construct simple circular curve in the field. So in this class, we have covered different angular methods of curve setting, and we have solved problems regarding chain and type methods of curve setting, as well as angular methods of curve setting. In the next class, we will solve some more problems in curve setting, and for this, and we will end the class here. I hope this class is helpful for all of us. We will have the next session in the next class. Thank you.